Once we have all this water, where are we going to store it? That is what a lot of people wonder. So that's what we're going to talk about in video 2. Water storage devices and technologies, which ones are best for permaculture. The first and most common water storage device that people encounter is the classic rain barrel. These are often available through local environmental agencies or local conservation districts at a very reasonable price. And this one was given to us for free. A lot of people have these, and when people move, they tend to trade them out. So the biggest advantage of these is simply their accessibility. They're pretty widespread, easy to come across, and super easy to install. You just route them from your gutters down into the barrel, and it's easy enough to do. As you see here, this one has a very simple mesh filter that keeps a little bit of debris out of it, leaves and organic matter, but for the most part, if you're using something like this, it's nice to route the water into biological filtering mechanisms such as we've done here with this overflow port that runs this hose right here down and into this swale system or gutter system. We'll talk about swales later. They go into this swale that feeds this forest garden, edible forest garden area here in our yard. So the biggest problem with these commercial rain barrels is simply their size. This one holds 50 gallons of water. But in 2 inches of rain, this part of our house might deliver easily 700 gallons or more of water. So in a pretty typical rain event, this thing is going to overflow many times over, and we'd be wasting a lot of the water. Which is really the big problem with rain barrels as a storage option. Even if you had one of these at each corner of your house, that's 100 gallons of water. Our home in an inch of rain would probably produce over 1,000 gallons of water. A second problem is simply with the quality of some of the materials that are often sold on these rain barrels. For much cheaper, you could go out and get better quality materials that are much more likely to last and take the test of time. And the final and probably biggest problem with almost all of these commercial rain barrels is that they just have these puny little hose-sized overflow ports. And they're very convenient for being able to hook a hose up to, as we have here. But they're not so convenient when it comes to actually being able to collect that water. Because at this point, at the top of the rain barrel, there's no head pressure or gravity pressure from the weight of the water to push the water through this hose. So the water is only barely going to trickle through there. Plus, you'll notice this hose port actually projects the hose on an upward angle. Basically, once this barrel fills up, that hose is going to get just a teensy trickle of the water that would be missed by the barrel. Which are all reasons that when I have the time, I'd rather make my own rain barrel. So this one, you see that overflow port there? Now that's an overflow port. As you can see, this one can handle all the rain that it would get, and it directs it down into a swale that takes it back up to that forest garden in the front of the yard. I can also outfit it for a much lower price with much high quality plumbing fixtures. Ones that I know are going to stand the test of time and be durable. So this one cost me about $1 or something, I think, to be able to fix up. As did the plumbing parts here. Overall, I probably spent about $30, including being able to make my own filter. These ICB totes are becoming widely available and can be configured together to store large amounts of water. Each one will store 250 gallons, and that could be all that you want all by itself, or you could configure them together. And they usually go for around $75 to $150 a piece in our market. To go bigger than that, you'd have to get one of these commercial rainwater cisterns. This is a 1,000-gallon one available through a company in Texas. Costs about $1,200, which is about par for the course for these. They come in 1,000-gallon, 3,000-gallon, 10,000 gallon or even more, and cost about appropriately. The big problem with these water cisterns in our climate, in Michigan's cold climate, or throughout the Great Lakes region is winter freezing, which will break the pipes at the very least, or break the cisterns themselves. Very large cisterns may be somewhat resistant to winter freezing, especially if they're insulated or have heat mechanisms, but for the most part, from what I've seen, freezing is usually a problem, unless you bury them under the ground. If you have more spare time than spare money, then the cheapest way to store water, according to water expert Art Ludwig, is in ferrocement cisterns, like these really cool looking ones from Oasis Designs. Now, again, the big drawback of these is that they're not impervious to winter freezing and can crack or be damaged. The plumbing can also be damaged much more easily than the cisterns themselves. So the key with all of these container-based water storage devices, from rain barrels to cisterns, is to really do your homework, do some good evaluation and planning to make sure that you're really going to get a return on your investment, especially if you're considering spending $1,000 on a cistern or the countless hours necessary to make something like a ferrocement cistern. How many gallons of water will you need to harvest and use for rainwater to pay off a $1,000 investment, or perhaps even more of an investment if you're counting your hours at a living wage and building something that's really labor intensive to both build and maintain? The problem is just having water quality that's good enough, that's clean enough, and safe enough, that doesn't require consistent testing to ensure its safety. So figure out how many gallons of water you need for your own operation. For example, for irrigation of your garden beds. Conventional garden vegetable beds, on the other hand, will require about an inch of water per week. So to give you a good rough guesstimate calculation about how much water you would need, for an 8x4 size bed, or a 32 square feet bed, that's 20 gallons of water per week, or 20 gallons of water per week. So a single water barrel would be able to water a garden of that size, assuming you didn't get any rain, for 2 weeks in a row. So one water barrel then would get you 2 weeks of drought proofing for that bed. Now, conserving soil moisture better using other techniques that we're going to talk about in these videos could stretch that water out even further. So one of the biggest questions to ask is whether you really need more irrigation water or whether you should invest in some of these other techniques instead. For example, here at Lily House, we only have a few beds at any given time, a very small space, probably something similar to that 32 by 20 area that require that kind of intensive watering, especially in the summer. In the summer, we tend not to grow those kinds of crops, save them for the wet seasons. But if we do want to grow them, we keep them to a very limited area. Then we do a lot of vegetables can be dry farmed for the hot summer, and we only irrigate those when they really need to be irrigated. Meanwhile, all of our forest garden areas almost require no irrigation at all. So from that perspective, we need very little extra irrigation or irrigation water to make our gardens here work and thrive. For home gardeners or farmers, this should be a major consideration. How much does your irrigation system and water storage system cost you? And how much is it going to pay back for the kinds of vegetables that you want to grow? Would you get a better return on your investment for dry farming and using some of these other techniques to conserve soil moisture? The answer is probably going to be yes, because university research on irrigation systems has found it very difficult to demonstrate and document a good return on complicated irrigation systems. Even the most efficient irrigation systems have typically failed that test. Drip irrigation systems in a few studies have clustered right around an increase of $7 per acre of profitability. So how many acres do you have to get to pay for a $1,000 irrigation system, and then with that $1,000 irrigation system even be suitable for that number of acres? Subsurface irrigation has had a much higher profitability rate. However, its increased cost, and especially its increased maintenance cost, most researchers have found it prohibitive and have thus not been able to recommend that either. And for permaculturists, there's another consideration. We should consider whether or not growing vegetables so far outside of their climate or outside of their season that they require such huge human intervention in order to thrive. We should consider whether or not using our time and resources to maintain those, especially if we're using lots of water and soil fertility and things like this, we should really consider whether or not that's really earth care, or whether or not we should stick more to the things that grow in season and that grow in our own climates the best. To review, calculate 0.6 gallons of water per week for regular garden beds. Or figure 20 gallons for a 32 square foot bed. Some of these systems are worth doing just for the cool factor, but there's no prize for overinvesting in irrigation. Which brings us to ponds, which are one of my favorite water storage systems. I think $1 per gallon, they're one of the most cost-effective ways to store water. And one of the reasons is that they stack functions. They don't just store water for you, but the pond itself can be a food-producing system. Things like water chestnuts are one of the highest producing crops per square foot you can grow, and watercress is one of the most nutrient-dense crops you can grow, and you can grow them both in a pond in our climate. Ponds are also one of the best ways to bring a lot of high-quality natural interactions into your forest garden ecosystem that'll improve the number of species and thus improve the health of all the plants in your system. Which brings us to the best water storage device of all, forest. Forest soils can catch and store almost 100% of the water that falls on them in any precipitation event, making them the most efficient place to catch water and to store it for later use. For example, in our gardens here at Lily House, we have surrounded all of our annual production in all of our garden areas with forest to catch and store water and then make it available to the plants when we need to. Since catching water and storing it in the soil is absolutely the lowest cost per gallon way we can do it, that is what we're going to focus on in the rest of these videos. So there you have it, a whole assortment of water storing devices and technologies that we can use in the permaculture landscape. Now, from my perspective, one thing to keep in mind is that the best technologies are always the simplest and the most reliant on nature. Whenever we can use something like a wetland or a forest to store our water and filter it for us, we're going to be saving ourselves a whole lot of money and a whole lot of time. And nature's techniques tend to be regenerative, durable assets that don't just last over time, but that actually get better at doing their job over time. Whereas human technologies tend to move in the opposite direction, taking further investments of time and energy to maintain them and keep them working properly. So if we overburden ourselves with a bunch of human-scale technologies that are man-made, each one of those is like adding a little bit of a to-do list to our life's task lists. But if we can create natural systems to do the same thing, then we're making less work for ourselves in the long term. So in a great permaculture design, our systems that we install don't just meet our own needs, but they actually help make the whole ecosystem stronger too. Because when we feed the ecosystem, it takes care of us.